Good day, you are welcome to my YouTube channel. My name is Catalyst and I'm a 100 level student of the prestigious University of Ibadan. So, this is my first ever YouTube video, a lecture video. I've been posting lectures on Facebook, I've been posting lectures on TikTok, but for YouTube, this one will be my first time. And today I'll be deferring this topic, scalars and vectors quantity, or let me just say scalars and vectors only. So, and I know that many students are facing a lot of problems to comprehend these topics, because that time when I was preparing for my UTME and I was in a group, so when they send a questions from this topic, people usually face a lot of challenges trying to get the answer. So I know that many students are still facing a lot of problems to comprehend this topic. So that's why I decided. And when I was also in secondary school, I also faced a lot of problems too. Though teacher explained, but for one reason or others, I couldn't understand it. So please remove any distractions. Remove any distractions and pay attention to this video, because the way I'm going to explain this topic to you, and the way there should not be any question that will come out from scalars and vectors that you will not get. Please pay attention to this video and then be attentive. Yes, be attentive. So now, scalars and vectors. You all know the definition of scalars. It is not new. It is not new. It's not a new thing, because most of you now, you are writing, you are praying for JAMBs and WAEC. So is SS2 works. So you must have done it. You must have heard about it. So scalars. Okay, let me just, we have fundamentals quantities and we have derived quantities. Of course, you know that. So out of that fundamentals and derived quantities, some of them are scalar quantities, and why some are vector quantities. Are you getting my point now? So out of that derived quantities, which are what? Volumes, densities, area, force, acceleration, velocity, pressure, those are derived quantities. And then the fundamental quantities, or the basic quantities, those one are mass, those one are time, those one are length, those one are moles. I get me now. So those quantities, part of them, they are scalars. Why some are what? Some are vectors quantities. So what is the meaning of scalar quantities? Scalar quantities are the quantities that have magnitude. What is the meaning of magnitude? Magnitude means size. They can be quantified. 20 kilograms, that's a magnitude. 70 degrees centigrade, that's a magnitude. 50 Newton, that's a magnitude. So those are for scalar quantities. But for vectors, vector quantities are those that have both. They have both the magnitude, means they have size, and then they have specified direction. If I say I walked for 20 meter. So this 20 meter, listen very carefully. This 20 meter is a scalar quantity. This is a distance. Distance is a scalar quantity. So this 20 meter is a what? It's a scalar quantity, because it's only specifying or telling us about the magnitude, which is for scalar. I hope I'm not rushing you. So this 20 meter is a scalar quantity, because I'm only specifying, I'm only telling you about the magnitude, the size of how much I walked. How far I walked. So this will be for distance. For distance. And distance is a scalar quantity, please. But if I now say I moved 20 meter eastward, 20 meter eastward. So you can see now, this quantity, it contains both the magnitude, which is 20 meter, and both this direction, which is eastward. I'm telling you the direction of my movement, eastward. So this one is now displacement. Displacement. So there's no how you specify displacement without specifying the directions. For those of you that are writing WAEC, if they ask you to calculate displacement, don't just write the fact, don't just write the magnitude. You must specify direction, whether it's what, whether north, east, whether west, whether south. You must what? You must specify the directions to get complete answer. So now, that's for scalars and vectors. I hope you are getting me so far. So now, let's move to resultant vector. So, resultant vector, from the word result, let me just define it. Though the way sometimes the way science defines some things could be a bit difficult for you to comprehend it. Yes, those are the problems many people are facing. Just because of how science defines some things, make it difficult for many of us to understand. Science will say a quantity is directly proportional to something. That direct proportional, sometimes many people don't understand. So I will explain it for you very carefully now. So resultant vector. Resultant vector is a single vector that will have the same effect of magnitude and directions as other forces put together. Are you getting my point now? Resultant vectors is a single, it's just only one vector. That's why this vector is not pluralized, it's a singular. So resultant vectors now is a single vectors that will have the same effect of magnitude and directions as other two or more forces combined together. Let me just do something for you. Don't okay, let just wait. Let's move to others now. We have parallel vector. I know what I'm saying. We're going to deal with that resultant vectors, because now we have parallel vectors. Parallel vectors. No, vectors now, they can be two, they can be three. I've pluralized it. Let's say this is a point here now. If a body move let me just explain the meaning of parallel for you first. Parallel means two lines that doesn't meet. They don't meet themselves. No matter how much you draw, how far you draw, how far you draw it, they can never meet. That is the meaning of parallel vectors. So this parallel vector now, let's say a body is here and one force is applied to it. Let's say a force applied to this object here is 20 Newton. 20 Newton. Let's say the body here is a box. It's a box. And one body applied a force of 20 Newton to this box. And another force, which is a vector. You know, force is also a vector. So another force too applied a force here. A force here of what? Of 30 Newton. 30 Newton. So these two vectors, they are called parallel vectors. They are called what? Parallel vectors. Because these two forces, they can never meet. Their lines of action can never cross each other. Yes, they can never cross each other. So these two lines, they are called parallel force or parallel vector. So now, the reason why I said we should wait a little bit for certain vectors, because I'm going to explain it here. That's why I said we should move to another one. So now, these are two vectors. The first one, 20 Newton, applying a force eastward, and another vector, 30 Newton, applied a force eastward, both directions. And these two forces, they are parallel force now. So if they ask you what is the resultant force, the resultant vector here, you see now, these two forces, they are acting on the same point, at the same point. So what is going to be the resultant? The resultant means the result. So the resultant now will be 30 plus 20. 30 plus 20, which is equal to what? 50 Newton eastward. Eastward. For vector quantity, there must be directions and there must be magnitude. Let me tell you the reason why. You know, this is a body here, and these two vectors, they are acting on at the same point. So these two bodies, they are reinforcing each other. So this body will actually move faster. Are you getting me now? They are going to move faster because these two bodies, they are acting on it at the same times, and they are facing the same directions. They are not opposing each other. So they are reinforced. This thing is, it is something very practicable. It's something you can do at homes. You know, when two people, when they are pulling something. So this thing will actually move forward. The effect of these two factors will be the additions. I'll get my point now. Will be the addition. 30 plus 20, that will be 15. In fact, it's even difficult for me to explain this thing because it is too simple. So now, that's for parallel factor. So let me use displacement 2. Let me use displacement for this explanation. If a body move um 30 meter eastward, 30 meter eastward, are you getting my point now? 30 meter eastward, are you getting my point now? And then it move again. You stop here and then it move again. You start again and then move again for 20 meter eastward again. So the resultant will be the addition of the displacement. The resultant will now be what? Will be 30 plus 20, which will be equal to what? 50 meter eastward. Are you getting my point now? I hope you are getting my point. So that is for parallel factors. Now for non-parallel factors. For non-parallel factors means factors that meet, that coincides, that cut each other's. Are you getting me now? Let's say for this one now, the box is here again, and a force is acting on this box, is applied to this box. Eastward, let's say the magnitude of this force is 50 Newton, and another force acting opposite to it, another force of 20 Newton acting opposite to this box. So this one now is called non-parallel factors because the angle between this force and this force is 180 degree. Are you getting me now? It's 180 degree. So they are non-parallel. They actually meet. So now, if you are asked to calculate the factor, these two forces, they are opposing each other. Are you getting my point now? They are opposing each other. But this force, this one is greater than this one. It is something practicable at homes. When you and your brother, when you are dragging something, you know, you are more powerful than your younger brother. You're more powerful than your younger brother. So that body will actually move towards your side because you are more powerful. So this body will actually move towards your side. The force, how fast this box will move towards this side depends on the difference between the two forces. Are you getting it now? How fast this thing will move to this side will depend on the difference between the magnitude of these two forces. So we all know that this box will move to this side because this one is more powerful than this one, and they are opposite each other. You know, the one I did, the first one I did, they are reinforcing each other. They are acting at the same direction. So the resultant for this one will be what? Will be 50 minus 20, which will be equal to 30 Newton. Which direction? This body will move towards this direction. That will be what? Eastward. 30 Newton eastward. That's for that. So let me just do one example for displacement as well. Please, just listen very carefully. If a body moves 30 meter eastward, I want you know this is a force and it's a factor. So I don't want to use displacement now. Also a factor as an example. So if a body moves 30 meter eastward, look at this very carefully. If a body moves 30 meter eastward and then move back 20 meter, when this body reaches this point, then it goes back 20 meter. So if you are Listen very carefully. Um, for for vectors, we say it have directions and it has magnitude. So there must be direction, there must be eastward, there must be specification, northward or southward. Now this body now, it move eastward for 30 minutes, for 30 meter, and then it go back for 20 meter. So for distance, the distance will be algebraic addition of these two movements. 30 plus 20, that will be what? That will be 50 meter. That is for distance. Are you getting my point now? But for displacement, displacement, let me define displacement. Displacement is the shortest distance, the shortest straight line from the starting point to the destination. So displacement doesn't care how much you have worked, your effort. What it cares about is the shortest distance from where you start to where you stopped. So this body starts from this point and then it ends here. So that means the displacement is going to be the distance from the starting point to the destination. That means you are only going to calculate the distance between these 2 points. This line, that is for displacement. Which is what? Which is 30 minus 20. That will be what? That will be 10 meter. What is the direction? Instead of going round like this and you are going here, instead of going around like this and going back here, so this way is telling you that why can't you just move straight to this point and stop here? This is the starting point and your destination is here. So displacement now is telling you that instead of you to be going around here and curving back here again, why can't you move straight from this place and stop here? So your direction will be what? Will be eastward, because you should move from this place to this place and stop here. That will be what? That will be 10 meter eastward. That's for displacement. Are you getting my point now? That's for what? That's for displacement. So perpendicular vectors. So this is for perpendicular vectors. Let me just do the perpendicular vector very quick. So these perpendicular vectors, we have talked about the parallel vectors and we have talked about non-parallel vectors and their resultant. So now perpendicular means 90 degree. Two vectors acting at 90 degrees to each other. So this is perpendicular vector. This is the first vector and this is the second vector. They are acting at what? At 90 degrees to each other. If your brother is here, your younger brother is here, and you are here, it is something that is practicable. So if a box is here, listen very carefully. If a box is here, it is something you can just think about and get the answer. I mean, you can just think about it and it's not something difficult. In fact, it's a very simple thing. If a box is here and your brother is here and you are here, just try it at home. And you tied a rope to this box. You tied a rope to this box and you hold it, and your brother too tied a rope to this box and he hold it. So you are moving this box to this side, and at the same time too, your brother too is holding, is pulling this box towards this side, northward. You are pulling eastward, your brother is pulling northward. So what is the resultant? Meaning that what is going to be the magnitude and the directions of this box? This box is now confused. It's now confused, like, where should I go? You are pulling here and someone is pulling here. So where should I go? So this box will now move this side. This box will what? Try it at home. This box will move this side. So these directions, this line is called the resultant. This line is called what? It's called the resultant. It's called the resultant. That is the result. Yes, that will be the result, the effect of these two vectors put together. I hope you are getting what I'm saying now. The first one, the first one I said, that if two vectors, they are acting, they are parallel force, they are acting at the same point together, so they are reinforcing each other. This box will actually move this side. Are you getting me now? But the second one, they are opposing each others. They are opposing each others. So this, the direction of this box will depends it depends on the difference between these two forces. If this one is 50 and this one is 30, definitely this one will move this side. This box will move this side because this force is greater than this force. But if they are not at angle 90 degrees to this, 90 degrees to each other, please, I'm rushing, I'm hurting, I'm hot. So if these two vectors, they are at 90 degrees to each other, this one at 90 degrees, so this box will move this side. It will not go this side and it won't go this side. So it is confused. This box is confused. It will now move this side. So this line or the direction of this thing is called the resultant vector. The resultant vector. So now, how do we calculate resultant vector now? Let me just do a little example for you. Though the next video, I'm going to be doing a lot of calculation on this topic. So if a body apply a force of 20 Newton northward on a point, a force of 20 Newton northward, 20 Newton, and another force apply a force of 30 Newton eastward, this is how JAMB will ask you. They now ask you that what is going to be the resultant. Like I have said earlier, that this body will move this side, will move this direction. So you're not going to draw a line like this. So this one is now the resultant now. So how do we calculate this line now? How do we calculate it? We are going to use the wisdom of mathematics. That's why I used to say that before you can tackle physics, you must have some knowledge at mathematics. Please go and master some topics in mathematics. Please and please. So now, how do we calculate this line? You see. So the way you are going to calculate this line is this. You are going to draw a line, a dotted line like this. So you are going to join this line to this point. So, you know, these things has now formed a triangle. Are we together now? This thing has now formed a triangle where this side will be equal to this side. So this one will now be called 20 Newton. So now, as I have gotten these two sides, that means that this side too now will be easier to get now. Since I've gotten these two sides, 20 Newton and 30 Newton, it is very easy for me to get this side. So this is a right triangle, and you know that in a right triangles, to get one of the sides, you must use Pythagoras theorems. Which state that r square or hypotenuse square is equal to this side square, which is b square plus c square. Please go and master this calculation very well at Pythagoras theorems. So this resultant square will now be b square. What is b square? 30 square. 30 square plus c square, 20 square. Which is equal to what? 30 times 30. That is 900. 900 plus 20 times 20, which is 400. 400. So r square, are you following me now? R square will now be 900 plus 400. That will now be 1300. That will now be 1300. So I'm going to take the square of this side. That will now be r square root 1300. Though I'm not with calculator, but the square root of 1300 should be something around maybe, let's just say 31, sir. Though I'm going to solve a lot of calculation tomorrow or the next videos, but this one I just want, let's assume that the square root of 1300 is 31 or 32. So this resultant now will now be what? It will now be 31 Newton. That is for magnitude. It's not done. we are still going to calculate the direction. Remember that vector has both magnitude and direction. So we must calculate the direction. Are you getting my point now? So the direction will be this angle. One problem I faced then when I was in secondary school is that I don't know. I used to like, what happened? Why is it that I cannot use this angle? So this is north. This is west. This is south, and this is east, and this is north. So this is the direction. This is the real direction of the resultant. So to calculate the directions of anything, you must use the angle between north and that line. Don't use this one. Oh, if you use this one, you are wrong. If you use the angle that is here, you are wrong. You're totally wrong. If the line is here, and you want to calculate any angle here, you want to specify a direction here, the angle you must calculate is the angle inclined to the south. Are you getting me now? The angle inclined to the south. I'm not going to use the angle inclined to the west too. If you get the angle inclined to the west, you are going to remove that angle from 90 and use that result to get the angle here. Are you getting me now? The same thing with this place. We are going to use the angle that is inclined to the south. Here too, we are going to use the angle that is inclined to the north, not the one inclined to the east. I hope you are getting my point now. So, to get the direction now, this one is 30 Newton. This one is 30 Newton. So to get the direction, you can see, there is no way we can get this this angle now. But there's something you can do. This angle is equal to this angle. We call it alternate angle. So this angle is equal to this angle. So we're going to get this angle. This angle is equal to this angle. So whatever this angle be will be this angle. So we're going to take this angle out. This triangle out, rather. So note this, you can only use Pythagoras theorems in a right angle triangle. Yes, you can only use Pythagoras theorems in a right angle triangles. And this formula, this thing I'm going to use now, I'm about to use another formula now. And this formula too, you can only use it in a right triangle triangle. You can't use it any triangle. Any triangle other than right angle triangle is wrong. So now, to calculate this triangle, I'm going to use SOHCAHTOA. SOHCAHTOA. So you know, I want to get this angle. So let's use sine. Are you getting me now? We have gotten this side too, which is the resultant vector, which is 31 Newton. So I can use any of these formula. So means sine is equal to sine theta is equal to opposite all over hypotenuse. This O means opposite. In fact, if you are a physics student, as soon as we explain this to you, you must have known this thing. K means cos theta equal to adjacent over hypotenuse. 2 means tan theta is equal to opposite all over adjacent. So now, let's use this angle and this angle. This one will be the opposite, and this one will be the what? The adjacent. The angle facing the right angle triangle is hypotenuse. So tan theta is equal to what? Opposite 30 all over adjacent 20. This one cancel this one. That will be 3 all over 2. That will be what? That will be 1.5. I will get now. So we're going to find the value of this angle here. That will be what? Though I'm not, I didn't prepare for any calculation here. So calculation is for another time. So if you press this in your calculator now, I don't know the angle it can give you. But let's assume that This thing now is 30 Newton. I'm sure it's not 30 Newton, but let us assume, press your calculator and get the final answer and put it there. Let's assume that this thing is 30 Newton. So theta is 30, 30 degree, not Newton. No. So this angle will now be what? 30 degree. So this angle will now be what? Will now be 30 degree. So the resultant will now be what? Will now be 31 Newton northeast. Not 30 degree east. That is the what? That is the value of our resultant. I hope you get what I just explained now. So that is for that. I hope you are following me. So the next one is diagonal vectors. So these diagonal vectors, they are vectors that the angle between them is either acute angle or obtuse angle. What is the meaning of acute angle? Acute angle is an angle that is less than 90 degree but greater than 0. So it must be greater than 0 and then less than 90 degree. Something like this. So that is acute angle. And the second one, which is obtuse angle. Obtuse angle is an angle that is less than 90 degree, but greater than 90 degree but less than 180 degree. They are greater than 90 degree but less than 180 degree. So they are something like this. Something like this. So this angle is greater than 90 degree but less than 180. The angle could be 120. This one could be something like 45 or 30 degree. So now, if you are now asked to calculate the resultant of two vectors acting at a point and they give you the angle, they can say, okay, two vectors AB. Let me just choose this one now. Two vectors AB acting at a point and the angle between them is 30 degrees. So they will ask you to calculate the resultant. Like the first one we did, the perpendicular vectors. So the resultant will be the what? The line between these two vectors. The line between these two vectors will be the what? Will be the resultant. But in this case, listen very carefully. So in this case now, in the case of diagonal vectors, angle less than 90 degree and then the obtuse angle, this diagonal is going to be the resultant. And you are going, the first one, we eventually change it to triangle. But this one, you are going to change it to parallelogram. Parallelograms. Parallelograms. Are you getting it now? So this diagonal what? This diagonal will be the resultant. This diagonal will be the resultant. So any vectors, any two vectors acting at a point with the angle between them less than 90 degree or the angle between them greater than 90 degree but less than 180, you are going to change that shapes. You are going to change it to parallelograms. For the perpendicular one, the first one, the one I did, I just sending it now. That one, you are going to change that one to triangle. So now this one, look at this now. They can tell you that the force of A is 10 Newton and the force of B is 20 Newton, for instance. So what I came here to do is just the explanation. Yes, I didn't come here just to do calculation. So just be pressing your calculator, but I will explain. So now, in this case, if you ask to calculate the resultant, in this case, you're not going to be using Pythagoras theorems or SOHCAHTOA. I told you that SOHCAHTOAs and Pythagoras theorem, they are only applied in the right triangle. You don't use them in any triangle. And this one is not a triangle. This one is what? Is quadrilateral. It has 4 sides. So we're going to be taking out, though there is 2 ways you can solve this thing. Yes, there is still, we are going to be using cos rule. Cos rule. Cos rule. This is cos rule. A square, B square plus, minus 2AB cos theta. Cos theta. So this is the cos rule. This is the original cos formula. But in this case, listen very carefully. The opposite side of parallelograms are equal. And the opposite sides of parallelogram are equal. And the opposite angles, they are equal. What I'm saying is that this angle, the angles that face this angle is also 30 degrees. It's also 30 degrees. Are you getting my point now? So this one, you know, the total angle in a quadrilateral is 360. The total angles of these 4 angles is 360 degrees. And since I have gotten the 2 angles, if you had 30 plus 30, that would be 60. If you remove 60 from this one, that would be 300. So that means that these 2 angles will share this 300. And these 2 angles, they are equal. The opposite side of parallelograms, they are equal. So that means that this one is going to be what? It's going to be 150 degrees. I hope you are getting my point. And this one too be 150 degrees. So if you are going to be using this angle to calculate this resultant, listen very carefully. In your textbooks, they use this angle to calculate the resultant. If you are going to use this angle to calculate the resultant, you are going to use this formula. That would be what? That would be r square. What is a square? 10 square plus b square, 20 square, minus 2 into brackets a times b, 10 times 20, which is 200, cos 180 minus 150. Do you know the reason why? The reason why we want to remove 150 from 180, because any cos theta that is greater than 90 will be minus. Yes, cos 90 is 0. Cos 90 will be 0. So any theta that is greater than 90 will be 0. So, and that means that cos 150 will be what? Will be minus something. So let's do it. R square will be what? Will be 100 plus 400 minus 2 times 400. That will be what? That will be 400 times cos 180 minus 30. 180 minus 30 is what? That will be 30. That will be cos 30. So what is cos 30? Cos 30 is 0.886. But we're not going to use 0.886. We're going to use minus 0.886 because what we are using here is 150. Are you getting me now? We're using 150. I told you that any theta that is greater than 90 degrees for cos will be minus. So cos, if we press it on the calculator, we are going to get minus 0.886. Minus 0.0886. So I'm not with calculator like I've said. So 100 plus 500 plus 400, that will be 500 minus times minus, that will be plus. Are you getting me now? So 400 times 0.886. Let's assume 400 times 0.886 is let's assume it is 230. Let's assume, because I'm not with calculator, let's assume it's 230. So 500 plus 230, that will be what? That will be 730. So to remove the square of resultant, we are going to what? We are going to square root 730. Whatever this thing gives you will be the what? Will be the magnitude of the resultant. So I have another formula where this minus will be plus. Where this minus will be plus. A square plus B square plus 2AB cos theta. Sorry. So in this case, use formula of this second one. Use the second formula. If you are going to use the angle, this angle between the two vectors, you know the angle we use for this one is 150. The angle between this one. But if you are going to use this direct angle, this angle between the two vectors, use plus 2AB, not minus again. Are you getting me now? So it will now be plus 2AB cos 30. So if you do it, you are still going to arrive at the same answer. Are you getting me now? The last one, which is the what? The resolution of vectors. In fact, I love this last one. I love this last one. Resolution of vectors. So we are talking about resolution of vectors. Let me use this example for you so that you can understand very well. Let's say you tied a rope to a nail on the wall. This is a wall now. This is a wall, and there is a nail on the wall. So this is a nail on the wall. So if you tie a rope to this nail, you are on the ground here. This is a man on the ground, and you tie the rope to this thing. So this is what we call resolution of vector. Listen very carefully. Resolution of vectors. This is a man on the ground trying to pull a nail on the wall. You can see these lines of action. It is neither vertical nor horizontal. What I'm saying is that this line of action, it is not vertical. This is vertical line, and this is horizontal line. So this line is not vertical, is bent line. Are you getting me now? So this thing is something that is practicable. As this man is pulling this thing, there will be effect of this force trying to bend this thing. Are you getting me now? So if this nail is not strong, this nail will be bent. So that means that the force trying to bend this nail is called vertical component or vertical force. Vertical what? Vertical force. The force trying to bend this nail. And at the same time, there will be a force trying to remove this nail. That force is called horizontal force, horizontal component. Are you getting the point now? So these vectors now, it has effect vertically. The effect trying to what? Trying to bend this thing down. And there's another force trying to pull out this thing. So we are not going to say resolute this vector horizontally or resolute it vertically. That means that you should calculate the effect, the force trying to what? Trying to remove this one, trying to remove this stone, this nail, which is what? Which is the horizontal force. Horizontal force, which is what? Fx, and the what? Fy. Very simple thing. Now, let me just rub this thing and let's do calculation, a little calculation on it. Let me use another example before the calculation. Let me use another example. Let's say there is a bag on the floor. You are dragging a bag on the floor. This is a bag on the floor. And you are dragging the bag. Let's say you hold the handle of the bag, or let's say you just tie a rope to maybe a toy and you are dragging it on the ground, on the floor. Look at this. This thing, this force too, is neither horizontal, vertical. Are you getting me now? It's neither horizontal. This is vertical, and this is what? This is horizontal. So, but this is the direction of your force. But this thing will be moving, right? This thing, this bag, it will be moving. So, and your direction is this side. This is your direction. But this bag is moving horizontally. So the force that is keeping this bag to move horizontally is called horizontal component. Horizontal component, which is what? Fx. Are you getting the point now? So this force, if this bag is a light bag, the bag that is not too heavy, you will see that the tip of this bag will be raising as you are dragging it. Have you ever dragged a toy, and the tip of that toy will be raising a little bit? So two things is happening. There is a force keeping this thing to move horizontally, and there's another force raising this thing up a little bit. So the force trying to raise this thing up is called the vertical force. Like the nail, the one trying to pull it out and the one trying to bend it. So if you are now asked to resonate it, resolution means calculate the effect, the force trying to what? To continue the motion of this thing, and the force trying to raise this thing out. That's the meaning of what? Resolution of vectors. Okay. If they ask you to what? To resonate it horizontally or resonate it vertically. JAMB cannot give you a question that a bag is being dragged on the floor and then the lines of action or a rope is inclined to the ground. Is inclined. This rope is inclined to the ground because I will represent this horizontal line as the ground now. It's inclined to the ground 30 degrees. 30 degrees. If they ask you that, calculate the horizontal force. Listen very carefully to this now. So in fact, this is the problems. Calculate this horizontal force, or calculate the vertical force, or isolate it. Now, listen very carefully. So people, you just cram everything. You don't even know whether it is cos theta or sin theta. Just listen very carefully now. So they can say that this force is 50 Newton. Yes, they will give you this force and they will give you the angle inclined. They can give you the angle inclined to the vertical, but usually they will give you the angle inclined to the horizontal. Though if they give you the angle inclined to the vertical, nothing is wrong. But usually JAMB usually asks the angle JAMB usually give the angle inclined to the horizontal. Now listen, if you are now asked to isolate this thing, so this one will now be what? This one will now be force. This one will be F. This one is Fy. This one is Fx. So if you are asked to calculate the what? The vertical, the horizontal component, that will be Fx. Is equal to what? Is equal to this force 50 cos theta. Do you know the reason why I use cos and not sine? I want to calculate this line, this horizontal component, and I use cos. Why is it that I didn't use sine? That is what many of you don't know. Yes, you don't know whether to use cos or whether to use sine. Yeah, listen now. Always use cos. Always use cos theta. Always use cos theta always use cos theta of the angles of the component you are trying to calculate. Always use cos theta of the inclined angle you are trying to calculate. Listen now. This is the component I'm trying to calculate. So I'm going to use the cos theta of that angle. I'm going to use the what? The cos theta of that angle of the component I'm trying to calculate. I can still use another angle. I can use the angle of this side to calculate this side. This angle of this side now will be what? Will be 60. It will be 60 degree. It will be 60 degree because this is now right angle triangle, and 90 minus 30 will be what? It will be 60 degree. I can still use this angle to calculate this horizontal component. Fx is equal to what? 50 sine. I'll now use sine because I'm not using the angle again here. I'm not using its angle. I'm not using the horizontal angle now. I'm not using the what? The vertical angle. I will now use sine theta. So if you calculate this thing, it is still going to result the same answer. It's still going to give you the same answer. 50 cos what? Cos 30 is what? Is what? That would be 50 times, because cos 30 will be what? Cos 30 will be 0.886. This one too. 50 times, what is sine 60? Because I'm going to be using sine 60. Sine 60 will be what? Sine 60 is 0.886. Can you see now? They are still the same thing. I hope you just get what I just explained now. I hope you get this now. So, if you want to calculate a particular component for this angle, always use cos theta of that component, of the angle of that component. If I want to calculate the vertical component, this vertical component, I hope, please, I don't want you to miss this side at all. I want you to understand this thing. If you're going to calculate the vertical component, you want to isolate this force. You want to calculate the effect trying to what? Trying to raise this bag upward, which is the vertical component. I'm going to say, okay, 50 cos, listen, no, I'm going to use the cos theta of the angle inclined to the horizontal, because this angle is belong to this side. So I'm going to use the cos. Use cos for the angle inclined to the component you are trying to calculate. Cos 60. I hope you get. Please pay attention to me. Please, my explanation is not too difficult to comprehend. They are simple things. So 50 cos 60. That will be 50. Cos 60 will be what? Cos 60 will be what? It will be 0.5. That will be what? That will be 25 Newton. I can still use sine, and I will still get the same answer. Fy is equal to what? 50 sine what? If you have to use sine, you're not going to use the angle of this component again. If you have to use sine, you're not going to use the angle of this component again. You are going to use the angle of the other one, which will be what? Which will be 30 degree. And 50 times 30 degree will be what? 0.5. Still what? Still 25 Newton. You are still going to get the same answer. I hope you get my explanation now. So if you know this thing, we are going to know how to calculate work done. Some of you just think, okay, work done is equal to what? Force times distance in the direction of the force. There are some calculations in work done that you need to isolate it. And also the moment of force, non-coplanar force, in equilibrium of force. Before you can also get that calculation too, you must know how to isolate vectors. You must know how to isolate vectors. Are you getting me now? Let me explain again. So I don't want you to miss this side at all. This resolution of vector, I never want you to miss it at all. Tomorrow, we're going to be dealing with a lot of JAMB questions. Only JAMB questions. Only JAMB questions. So look at this now. Let me rub all. Because I know some of you still yet you don't understand though. You don't understand still. So this is 50 Newton. And this side is 30 degree. And this side is 60 degree. Are you getting my point now? So this force is 50 Newton. This force is not resultant force. So This one now, we have moved past the resultant force. We're not talking about resultant force again. Now we're not talking about resolution of vectors. That if hmm, that if a body is air, if a body is air, and a rope is tied to this body, and this body is being pulled along this side, this body will be moving, Abby. It will be moving horizontally, and at the same times, there will be a force trying to what? Trying to raise this body. So the force trying to raise this body is called the vertical component, and the force trying to what? To keep this body in motion. I mean, the horizontal movement is called the horizontal component. So to calculate that force, we are going to resolute this thing. That's why we call it resolution of vectors. And I told you that if you want to calculate this component, this fx, the horizontal component, that will be fx is equal to what? Number one, 50. And if you are going to use cos, in fact, that cos is the one you just have in your mind. If you are going to use cos theta, make sure you use theta of the side you are going to calculate. I want to calculate this side now. If you are going to use cos, use the cos of the inclined angle you are trying to calculate. Like now, 50 cos 30. If I say 50 cos 60, I'm wrong. This is very wrong. If you say 50 cos 60, that is very, very wrong. Because you are using the angle of this side, of this vertical one, and we are calculating the horizontal component. Or use fx is equal to what? 50. If you are going to use 60, you are going to use sine 60. The vertical component. 50 cos, you see, 50 cos 30, I'm using the angle of the horizontal component. The same thing with vertical component. I'm going to use the cos angle of the what? Of the vertical component, cos 60. Or the same answer. This thing and this one will give you the same answer. This one and this one, they give you the same answer. Fy is equal to what? 50 sine, then the angle of the other side, which is what? Which is 30 degree. Which is 30 degree. That's all. That's all. I hope you understand. So the next video, we're going to be after the calculation aspect, I'm going to be doing finding the resultants of vectors more than two. The one we have been dealing with, there are two vectors. But in this case, we're going to be finding the resultants that are more than two vectors. Like this thing. Try something like this. Are you getting me now? So we're going to be applying two things here. First, we're going to resolute it. Then after resolution, we're going to now find the what? The resultant of these vectors. So subscribe to this channel. The next video, I'm going to be solving JAMB past questions. The JAMB past questions on vectors and scalars. Are you getting me now? On vectors and scalars. So make sure you like this video and share and follow, please. Make sure you follow. Thank you so much.